Hello everyone, my name is Tunahan Işık. This year we will study physics for 8th grade together. I shared the link of a booklet for you, so you can find the download link below this video. That because it's our first lesson, I want you to know that I will try to make the lesson as much as short, attractive and productive and fun. So first of all, I would like to start introducing the subjects that we will cover this year. First, introduction to physics, matter and measurement, force, simple machines, heat and its effect on materials, measurement of heat, heat transfer, static electricity, and finally, magnetic field generated by magnets. Okay, in the first chapter, Introduction to Physics, I will mention about the description of physics, the history of physics, and branches of physics. Well, let's start with the defining of physics. Science is divided into three parts: biology, physics, and chemistry. The main purpose of these subjects is to study and try to understand the whole universe and everything in it. Well, what is physics anyway? Physics is the branch of science which deals with matter and its relation to energy. It also includes physical and natural phenomena. Okay, let me give you some examples about these phenomena. For example, the formation of rainbow, the occurrence of eclipse. As you can see, this one is solar eclipse and this one is lunar eclipse. The fall of object up to down. The cause of sunset and sunrise. Sunset and sunrise. And the formation of a shadow. And many more. In general, we can examine the physics in three main parts. I call this one as the map of physics. First, classical physics, relativity, and quantum physics. Well, you will going to study only the subjects belongs to classical physics throughout the high school. Later in the university, maybe you will study relativity and quantum physics. So, let me introduce the branches of classical physics. We have 7 of them. The first one is motion and gravitation, optics, waves, electricity and magnetism, or we call electromagnetism, classical mechanics, fluid mechanics, and finally thermodynamics. Well, there is no doubt that the father of classical physics is Sir Isaac Newton. Isaac Newton is an English mathematician, physician, astronomer, and author who is widely recognized as one of the most influential scientists of all time and as a key figure of scientific revolution. So he invented calculus and the laws of motion and the laws of universal gravitation. He also many discoveries in optics for the first time in the history. So let's start with the classical physics, so motion and gravitation. By the way, can you guess which one is Isaac Newton? This one is Sir Isaac Newton. His laws of motion describe how everything made up matter moves about. The universal gravitation ties up the planets in the sky with falling objects on Earth into one general and elegant description. So, however, calculus is a real part of mathematics. Physics and mathematics are inseparable. Well, it turns out that we can surely say mathematics is the language of physics. Okay, let's continue with optics. Newton had made stride in optics, which is the physics of light and how light travels different materials. Well, it explains the refraction of which has seen in prisms, lenses, telescopes, microscopes, and cameras. And the other one is waves. Optics is closely related with the theory of waves, which is basically how energy transferred in a medium. For example, ripples on a lake or sound in the air. Okay, let's continue with electricity and magnetism, which is also we can call electromagnetism. Electromagnetism is described of magnet and electricity, or more generally, electric and magnetic fields. Well, it was a scientist named James Clerk Maxwell. This one, James Clerk Maxwell. Maxwell, who discovered that those two are aspects of the same thing, and he derived that the wonderfully and elegantly rules of electromagnetism. And he also theorized that the light was an electromagnetic wave. Electromagnetism also explains all of electricity. Okay, let's continue with classical mechanics. Classical mechanics is all about Newton's laws of motion, and it covers the properties and motion of solid objects, how they move when forces act on them, and what's going to happen when they are joined together, like gears, buildings, and bridges. Fluid mechanics. Fluid mechanics is the description of the fluid of liquids and gases. Using fluid mechanics, we can work out how much lift is generated from an aeroplane's wing, or how aerodynamic a car is. So, finally, thermodynamics. Thermodynamics is the description of energy, how it passes from one form to another, solid to liquids, liquids to gas. Thermodynamics also includes entropy, which measure order and disorder. Entropy tells us how useful different kinds of energy are. Okay, classical physics, that's all. And energy, I want to talk about about energy. Energy is the fundamental property of physics. Also, I just talked about energy here on thermodynamics. I have written all the board about energy, because everything is all about energy, and everything with a mass has energy. So that's all about classical physics, the picture of the universe we had around 1900. I would like to give you the second main part of physics, which is relativity. Albert Einstein was the genius who developed the theory of special and general relativity. So, special relativity predicts that the speed of light is constant for all observers, which means that when you travel really fast, weird stuff starts happening, like time is slowing down. Special relativity also states that mass and matter are two aspects of the same thing, through the famous formula of Albert Einstein, which is E is equal to mc square. Energy is equal to mass times square of speed of light. Okay, if you are interested, you can find more information about relativity and quantum physics about somewhere here on the video. If you have any questions, please don't hesitate to ask. As a quantum physicist, I will be glad to answer them all. So, thank you for joining me today. In the next video, we will study matter and measurement. So, until the next time, see ya.